There was a time when the earth was ruled by giants, when continents breathed forests and the skies trembled with wings wider than modern aircraft. It was the late Cretaceous period, about 66 million years ago, and the world was alive in ways almost unimaginable today. Vast plains stretched across what would become North America, filled with towering conifers, cycads, and ferns that thrived under a warm, humid sky. The air carried the scent of resin and the heavy hum of insects as large as a man's hand. Herds of herbivorous dinosaurs moved slowly through the greenery. Triceratops, ankylosaurs, hadrosaurs, each adapted perfectly to its environment, each part of a balanced and ancient ecosystem that had evolved for over 150 million years. On these fertile plains, the great predators ruled the shadows. The most formidable among them was Tyrannosaurus rex, a creature 30 feet long with teeth like daggers, a hunter whose senses were honed by evolution into an almost perfect machine. The oceans too teemed with giants. Marine reptiles like mosasaurs and plesiosaurs patrolled the depths, feeding on schools of fish and ammonites that glowed faintly beneath the waves. Above, in skies of endless blue, enormous pterosaurs glided on the thermals, their leathery wings casting shadows over the coasts. The planet at that time was warmer than it is today. Sea levels were higher, creating shallow inland seas that split continents and gave rise to lush coastal ecosystems. Coral reefs flourished, and volcanic islands speckled the oceans. It was a world full of energy and movement, every living thing locked into a delicate web of survival. Life had endured countless challenges: ice ages, supervolcanoes, continental drift, but the Earth of the late Cretaceous had reached a new equilibrium. Evolution had perfected the art of adaptation. Dinosaurs dominated every niche on land, from the forests of Asia to the river deltas of South America. Their reign seemed eternal, written into the very soil of the planet. Yet, far beyond the clouds, in the silent darkness of space, destiny was already in motion. A massive asteroid, roughly 10 kilometers across, had been wandering through the solar system for millions of years. It was a fragment born of an ancient collision, a rogue body drawn slowly inward by the gravity of larger worlds. For eons, it drifted unnoticed, a silent traveler between Mars and Jupiter, until a series of subtle gravitational nudges altered its course. Slowly, imperceptibly, it began to fall toward the inner solar system, toward Earth. At that moment, no creature on the planet could comprehend what was coming. The dinosaurs continued their daily rhythms, the herbivores fed, the predators hunted, and the forests rustled with life. But high above, in the void, the asteroid approached with a force beyond imagination. Its journey would end not in space but in the shallow seas off the coast of what is now Mexico, on the Yucatan Peninsula. The place that would one day be called Chicxulub was then a calm tropical shoreline, rich with coral reefs and mangroves, its waters teeming with fish and marine reptiles. The asteroid's final approach began silently, unseen, its shadow still far from the planet. It traveled at over 70,000 kilometers per hour, faster than a bullet, unstoppable by any force of nature. As it entered the upper atmosphere, friction heated its surface until it glowed brighter than the sun. A trail of incandescent plasma stretched across the sky, and for a brief moment, the daylight intensified to a brilliance no living creature had ever witnessed. In that instant, the balance of the world ended. The asteroid struck the Earth with an impact that released energy equivalent to 100 trillion tons of TNT. The shock wave vaporized everything within hundreds of kilometers, turning ocean water into steam and rock into liquid fire. A crater 180 kilometers wide was gouged into the crust, its edges collapsing inward as molten material sprayed into the sky. The explosion ignited forests thousands of kilometers away. The impact's heat flash was so intense that it scorched vegetation across entire continents, setting the atmosphere itself ablaze. Debris, molten rock, and vaporized minerals were hurled beyond the atmosphere, spreading into orbit and beginning their deadly descent back to the surface as incandescent rain. Within minutes, the entire Western Hemisphere was alight. In the seas, shock waves tore through the water, killing marine life instantly. A megatsunami over 1 kilometer high raced outward across the Gulf of Mexico, crossing oceans and slamming into coastlines around the globe. The force of the impact triggered earthquakes and volcanic eruptions as far away as India, where the Deccan Traps, already active, began to release even more lava, ash, and carbon dioxide. It was a chain reaction of destruction. The world's crust rang like a bell. Day turned to night as billions of tons of dust, ash, and sulfur were thrust into the upper atmosphere, forming a shroud that began to encircle the planet. In the hours that followed, the Earth itself seemed to convulse. The fires burned for days, fueled by trees, plants, and even the oxygen in the air. Temperatures soared, then plummeted as the dust cloud thickened, blocking out the sun. Photosynthesis ceased almost immediately. The lush forests that had sustained herbivores began to die. When the plants died, the herbivores starved. When they fell, the predators followed. 4 weeks after the impact, the planet was a vision of chaos. The skies glowed a dull red from the constant fall of molten ejecta re-entering the atmosphere, a rain of fire that circled the Earth several times before fading. Each returning fragment ignited the air around it, generating shock waves and sparks that lit new wildfires in regions untouched by the first inferno. Within months, much of the planet's vegetation was gone, reduced to ash. The once green continents were now a patchwork of charred plains and blackened forests. As the fires subsided, another kind of darkness took hold. The fine dust and aerosols suspended in the stratosphere began to block sunlight almost completely. Global temperatures dropped by more than 30 degrees Celsius. Photosynthesis, the process that powered nearly all life, stopped. The oceans cooled and turned acidic as sulfuric compounds mixed with water vapor, forming toxic rain that fell for years. Plankton, the foundation of marine ecosystems, perished in vast numbers. Without plankton, the larger creatures of the sea ammonites, mollusks, and fish starved, and with them the great marine reptiles that had ruled the oceans for millions of years. On land, conditions were no better. The dust-choked sky allowed only a faint twilight at noon, and that too dim and cold to sustain life. Temperatures near the poles plunged below freezing, while the tropics, deprived of sunlight, became deserts of soot and silence. Herbivores like Triceratops, once abundant, wandered aimlessly through landscapes stripped of plants. Some collapsed where they stood, their bones later to be buried in the new layers of ash that marked the boundary between the Cretaceous and what would become the Paleogene. Tyrannosaurus rex, the apex predator of its age, found no prey left to hunt. Its massive frame, built for power and speed, became a burden in a starving world. One by one, the great hunters fell to hunger and cold. Across the globe, ecosystems that had taken tens of millions of years to evolve unraveled in mere decades. But while most of the dinosaurs perished, not all life was extinguished. Deep within burrows, small mammals, creatures no larger than a rat, found refuge from the burning skies. In lakes and rivers, amphibians and reptiles survived beneath the water, shielded from the worst of the heat. Seeds buried under layers of ash endured the long darkness, waiting for light to return. Microbes in the oceans adapted to the chemical changes, forming the base of a new food chain. In these pockets of survival lay the foundation of the next chapter of life on Earth. The impact that ended the reign of the dinosaurs did not destroy life completely, it reset it. As the years passed, the dust in the atmosphere slowly began to settle. Volcanic activity continued for centuries, but gradually the skies cleared enough for sunlight to filter through once more. When that first weak light touched the surface, it found a planet transformed. The lush forests of the Cretaceous were gone, replaced by a barren wasteland of ash and rock. Yet even here, in the cracks between stones, the first green shoots appeared, ferns and mosses reclaiming the land. With the return of the plants came insects, and with insects, the small animals that fed on them. The world was quiet, stripped of its giants, but it was alive. The oceans, though changed, began to recover as well. The surviving plankton multiplied, spreading color back into the waters. Small fish returned, feeding on the microscopic life, and in time, larger creatures followed. Evolution, relentless and creative, began to fill the empty niches left by extinction. It was a slow rebirth, measured not in years but in millennia. The climate stabilized, the air cleared, and a new balance emerged. The Cretaceous was over, and the Paleogene had begun. In the absence of dinosaurs, mammals once small and insignificant rose to prominence. They diversified rapidly, evolving new forms, new strategies for survival. Some took to the trees, others to the open plains, and some to the water. The world, scarred but fertile, became a laboratory for evolution. The extinction that had seemed an absolute end now revealed itself as a beginning. Fossil evidence shows that more than 75% of all species vanished during the event, yet from that loss came the ancestors of modern birds, mammals, and eventually humans. The impact site at Chicxulub, buried beneath layers of sediment, remained hidden for millions of years, its secrets locked within the rocks. Only in the 20th century would scientists uncover the evidence of the asteroid's role in the mass extinction, the global layer of iridium-rich clay, the shocked quartz, the gravity anomalies beneath the Yucatan. These discoveries transformed our understanding of planetary history, revealing that even the mightiest creatures could fall to forces from beyond the Earth. Today, the story of the dinosaurs' end stands as one of science's greatest lessons, a reminder of both the fragility and the resilience of life. The dinosaurs, magnificent and ancient, ruled the world for over 160 million years, yet their extinction paved the way for the rise of mammals and, ultimately, humanity itself. When the first sunlight returned to the cooling Earth, it illuminated a planet reborn from chaos. The continents were scarred, the atmosphere still veiled in haze, and the oceans carried the chemical imprint of destruction, yet life was stirring once more. The earliest Paleogene world was one of survivors: small mammals scurrying among ferns, insects crawling over charred wood, and birds, the last living descendants of the dinosaurs, taking to the skies once again. The evolutionary advantage of small size, warm blood, and adaptability allowed these creatures to endure where the giants could not. Forests began to spread across the continents anew, first with ferns and palms, then with flowering plants that had survived in hidden refuges. Rain returned, washing away the ash and giving birth to rivers that carried nutrients back to the seas. In those rejuvenated waters, microscopic algae bloomed, forming the basis of a new marine ecosystem. Over thousands of years, ecosystems began to stabilize, though they looked nothing like the world that had existed before. Without the great reptiles to dominate the land, the mammals diversified rapidly, evolving into new forms. Some grew larger, exploring the open plains that the dinosaurs had once ruled, others adapted to the trees, gliding or leaping in search of fruit and insects. The world had entered a new evolutionary age, one shaped not by size or strength but by intelligence, adaptability, and endurance. The geological boundary that separates the Cretaceous from the Paleogene remains visible today in the fossil record, a thin layer of clay enriched with iridium, an element rare on Earth but common in asteroids. This global scar marks one of the most dramatic transitions in the planet's history, a silent witness to the day the Earth changed forever. Scientists studying this boundary have pieced together the sequence of events: the asteroid impact, the global fires, the years of darkness, the collapse of food chains, and the slow recovery that followed. From this evidence emerges a story not only of catastrophe but of renewal. The extinction of the dinosaurs was both an ending and a beginning, a moment when the balance of life shifted and new possibilities arose from ruin. Over the next 10 million years, the world continued to heal. The Deccan Traps in India, whose volcanic eruptions had been intensified by the impact, eventually ceased, allowing the atmosphere to clear completely. Carbon dioxide levels dropped, the climate cooled, and new temperate ecosystems developed. Mammals grew larger, evolving into the ancestors of elephants, horses, and primates. Birds diversified into countless species, filling the ecological roles once held by pterosaurs. The Earth had entered the age of mammals, and from this lineage would one day come the primates, apes, and ultimately humans. Every living creature today, from the smallest shrew to the largest whale, carries within its DNA the legacy of those that survived the Cretaceous-Paleogene extinction. The asteroid that struck the Earth 66 million years ago reshaped not only the surface of the planet but the trajectory of life itself. Without it, dinosaurs might still walk the land, and mammals might never have risen beyond the shadows. The impact at Chicxulub stands as both a warning and a testament, a reminder that the universe is not a passive backdrop but an active participant in the story of life. Planet Earth, fragile and resilient, continues to orbit the same star under which the dinosaurs once thrived. Every mountain, Every grain of sand, every fossil embedded in the rock is a fragment of that story, a memory of a time when the world burned and was born again. The silence that followed the extinction was not the end, but the pause before the next great symphony of evolution. Over millions of years, continents drifted, climates changed, and life diversified once more. The blueprint of survival was rewritten, favoring creatures that could adapt quickly to change. This adaptability would become the hallmark of all future life on Earth. In the layers of limestone and shale that once formed the Cretaceous seabeds, paleontologists uncover the frozen remains of that vanished era: bones of Triceratops, teeth of T-Rex, and the delicate imprints of ancient ferns, each fossil a message from the deep past, each a testament to the transience of domination. The Age of Dinosaurs ended not in a single moment, but in the slow unraveling of ecosystems that could no longer sustain themselves under the shroud of darkness. Yet from their extinction rose the dawn of modern biodiversity, a living continuum that stretches unbroken to our own time. The Earth did not die on that day in the Yucatan, it changed, and in that change lay its greatest strength. The same forces that destroyed the old world gave birth to the new. In this way, the story of the end of the dinosaurs is also the story of resilience, the ability of life to endure, to adapt, and to begin again. Even now, the Chicxulub crater remains buried beneath layers of rock and sea, but its mark is eternal. It reminds us that extinction is both a natural process and a creative one, that every end carries within it the seed of a beginning. The dinosaurs, though gone, live on through their avian descendants, through the genetic traces preserved in the creatures of today, and through the very existence of the mammals that succeeded them. The cataclysm that ended their reign forged the world we know. The forests we walk, the air we breathe, the diversity of life that surrounds us all are products of that ancient night of fire and ash. And as we look to the stars, searching for the origins of our own existence, we are reminded that we, too, are part of the same cosmic story that began when that fragment of rock left its orbit and fell toward a blue planet full of life. The end of the dinosaurs was not merely an extinction, it was the resetting of evolution's clock, the moment when the path of life bent toward a new future. It was the end of an age and the dawn of everything that would follow.